Right, thank you everybody for joining us tonight for this meeting of the Warren Astronomical Society. I am Diane Hall, your president for this year, and this is of course the meeting that we would be having at Macomb Community College were it not for the COVID pandemic. So glad to see you all, and we'll kick things off with the officers' reports. The officers are in discussion about how best to ease back into in-person meetings, if that's feasible, what impact it'll have, what it'll take. And while the future of in-person meetings at Cranbrook and Macomb is still very much up in the air for this year, we are looking forward to bringing you an in-person outdoor picnic. So we're in the very preliminary stages of getting that up and running, but we hope to be able to entertain y'all safely at the Wolcott Mill Pavilion this summer. So stay tuned for news on that. And I would like to pass things to Dr. Dale Parton, our program chair.
Thank you, Diane. Looking ahead at our speakers for the next couple of meetings, at the next meeting on April the 5th, our speaker will be Annie Blackwell, back by popular demand, to give our main presentation. You may recall that she's working on her doctorate in astronomy at the University of Michigan, and she gave a short presentation to us a few months back on black holes. Did a really nice job. She will be giving our main presentation at our next meeting, entitled Supernova Remnant Kinematics and Cluster Metallicity, X-ray Mysteries. That may sound challenging, but I can only say that based on her previous presentation, she has a way of bringing astronomical presentations down to earth. The short presentation that night will be given by David Levy. His presentation is characteristically on the long side. It is of Schmidt cameras, comets, and asteroid Bennu, a long friendship with Rick and Dolores Hill. We'll have to wait and see what all he puts into that. Then, a month from now, on April 15, our president, Diane Hall, will have the main presentation entitled The Galileo Mission. I'd like to say that it's nice to have these nice presentations, but it takes people who are willing to do some work to give these presentations, to prepare these presentations. And we need speakers. So if you've got some idea that's kind of been floating around in the back of your mind for a while, or some recent inspiration, I'd certainly like to hear about it. You don't have to give a full-length presentation. You can give a short one if you'd prefer. But we need speakers. Enough said. Diane, back to you.
Thank you, Dale. Yep, one of the great things about this club is the sheer number of original presentations that our members have been able to put together over the years, supplemented, of course, by visitors and by people from other clubs. But this has always been a great club for presentations, and we're hoping to get some more people on the docket.
Diane, may I ask a quick question? Do we ever pay for presentations? Or is it always expected that it would be?
In certain cases where travel is involved, say that somebody comes over from, we've had people come from Illinois, Ohio, there might be an honorarium or a travel fee in the past.
Okay.
The club does have a policy on that now, a set reimbursement, but no, we don't normally, outside of travel expenses, we
Okay.
don't normally pay.
All right, thank you.
Yes, thank you. And I will now pass things to Riyad Mahdi, our observatory chair.
Thank you, Diane. Hello, everyone. I visited the observatory a couple of weeks ago on the 1st. Everything is in good shape. All the equipment is there. Both buildings are okay. Basically, we're just waiting, as Diane already mentioned, to see if we can maybe start to have gatherings of some sort, maybe after most people would have had the chance at least to get their vaccines. And hopefully maybe we can have a picnic sometime late summer of this year. Fingers crossed, we'll see what happens unless we have another fourth wave of people getting sick or something like that. The state shuts down again. Short of that, hopefully we'll start to see each other back, at least at the observatory in the open air, where things can still be safer than before, for sure. And that's all I have for now. Thank you.
Thank you, Riyad. I'd like to pass things now to Secretary Mark Kedzier.
Hello, everyone. As secretary, I have nothing to report tonight. Just going to be taking minutes, so speak clearly. All right. That's all I have, Mr. President.
Good deal. Thank you, Mark. And Mark has also been collecting our mail from the mailbox and then handing it off to. Next in line, Treasurer Adrian Bradley.
All right, well, I'll try and make this pretty quick. I've got access to the account, including online access. Checks that have been hanging around, if you sent in or mailed in your membership fee, renewal fee, it has been cashed. I do have from Mark 7 more that will be deposited because now I can do them automatically from my phone as well as keep up with balances. So I'm getting the account to where I have complete mastery of it. Totals are $21,905.56 in the main account, $3,375.18 in the GLAC account. The GLAC account will be giving a reimbursement. There's a reimbursement that I processed for GLAC member Jeff Kopmanis for the $95 he spent for AATB. That is going to come out of the GLAC account. So those numbers there will be a transfer of funds so that the main Warren account and the GLAC account remain separate as far as what's paying back who. So I'm going to continue to work on this. I will be able to get a handle on cash flow in and out. Another important thing to mention before I'm done, in the latest statements, it mentioned that certain fees for accounts were no longer going to be waived. We are comfortably over the minimum balance of $15,000, so we are not paying a fee, but it does mean that if you want to embezzle the account and buy that telescope, we have fees to pay at the end of each month. So we're probably not going to do that. We have a working capital essentially of $7,000 to avoid having to pay fees each month. And I will be digging further into the ins and outs of our account as I go along. As everyone may know, I work at a bank, even though I do IT for it. I like to make sure money is tight. So we'll be continuing to do some work on that. Thanks to Mark Kedzier, Dale Timmy, Diane, you and Jonathan, and Mark J for helping me out so far. And any questions about your payments, you all can send me an email. I'll put my email in the chat and I can look you up. Membership, we are, and I'd hope to have this up. I wanted to give you guys this before we quit. Membership, I think we're around 170 paid members. Let's get the exact number. And it is, oh, come on, mouse. And I'll turn this over. Numbers I have are 167. We've got 7 more, so add 774 paid renewals and memberships. So that is where we are. That is the end of my report. My email will be in the chat for those that want more information. Thank you all for bearing with me and listening.
Thank you, Adrian. All right, on to Bob Trembley at Outreach.
Evening, everyone. Well, my outreach report is in the WASP, and the first thing I cover in there, the first page, is April is Global Astronomy Month, and there are a whole bunch of astronomy events happening that month. I would like to see something done. I'm actually thinking of doing what I'm doing tonight again on Yuri's Night, which is April 12th, and which is a celebration of Yuri Gagarin becoming the first human in space. And serendipitously, the launch of the first space shuttle on the same date, but it's Yuri. But so it's called Yuri's Night. And so we also got meteor shower in the middle of the month, end of the month, and Earth Day, and a supermoon. I know I hate the term, but hey, the public knows it, and it might be a good thing to plug. So a lot of things happening in April. I'd like to see us do something. I said I haven't got a flyer or anything for my Yuri's Night thing yet, but I will be doing that. I'm not sure how I'm going to be broadcasting it yet, but I'll figure that out. We have several people under the member spotlight. Ken Burton has done some more stuff with students. Adrian Bradley's light pillar image was shown on spaceweather.com. Go, Adrian. Bob Berta has given presentations to Scouts and Oakland University Astronomy Club. I gave a presentation for the Detroit Public Library, which I have to do more of. Jonathan Cade gave a presentation about things we've sent to Venus to the Seven Ponds Astronomy Club. Angelo gave a presentation about the solar system at St. Peter's Elementary School, and Bob Berta gave another presentation to some Boy Scout troops. Actually, this was in December, but I didn't report it. I just found out about it. So I hope you guys are doing things safely. But if we can do things safely, yay, that's really good to see us doing that many things. There's a link there. If you've done an outreach event, let me know about it. And that's it for my report.
Thank you, Bob. And off to Dale Teamy at Publications.
Thank you, Diane. Just need to report tonight that the WASP is still up. So if anyone wants to check it out, they can go to our website and download a copy of it. And it was, what month is this? March? Yeah. So the April WASP is shaping up to be a pretty good one too. So a little something to look forward to. Thank you, Diane.
Thank you, Dale. And Dale also sent me this marvelous 3D printed shuttle lamp. Yeah, I see Bob reaching out for that. Yeah. Yeah, got that just this week from Mr. Teamy. So very nice.
You're welcome.
All right, let's pass things to the subgroup. So in brief, solar. Anybody got some live picks? There was a group that came around the limb of the sun last week, but from what I saw yesterday, things weren't super exciting. Double star group will reconvene whenever we get back to Stargate.
Yep.
Astrophotography, got anything going on there, Bill?
Yes, I have a image to show here. This was taken up here at my observatory in Cadillac. Can everybody see that? Okay.
Yes.
This is NGC 3628, otherwise known as the Hamburger Galaxy. This is a spiral galaxy that's edge on to us right now. So for those of you who are not familiar with spiral edge on galaxies, take a saucer, and if you hold the saucer up, we consider that face on. And if you tip the saucer where you're looking at the edge, then that's what you're seeing here. What is peculiar about this galaxy is the dust lane going through. It goes this way as well as this way. So it's pretty peculiar. I was reading a few researchers claim that this may be due to two interacting galaxies coming close to each other. That's one theory. But I thought it pretty interesting galaxy to show. This is 3.5 hours of integration time with my one-shot color CMOS chip camera. And this is located in the constellation Leo, which is visible, you know, in fairly decent skies with probably an 8-inch or larger telescope. You can see some pretty good detail in it. So I just thought I'd share that with you, just because I think it's two interacting galaxies coming together.
Very nice. Thank you, Bill.
Yep.
All right, and history group's adventures get chronicled in the WASP when they have been up to things, and merchandise in Astronomical League. Well, the merchandise is all at our house, and we can't really sell it to you. And the Astronomical League's window has closed for the 6-month period between now and June. So I think we can carry on to. Thank you for sharing the sun there. Yes, very nice. Carry on to observing reports. And we got David Levy first in the queue. Hello, David.
Hello, everyone. Hello, everybody. It's wonderful to be here again. And I just wanted to say that I know that the title for my talk coming up next month, the short talk, is a very long title. And I promise you that the talk will probably be shorter than the title is. But so I hope it won't frighten anybody. We've had an interesting observing experience here. I was out just last night getting my favorite variable star with my visual telescope, Miranda, 16-inch. And I can't do it photographically right now because all of the my observatory building is being repaired. The roof has been taken off and all the telescopes closed up and covered inside it. But I'm hoping that we'll be back and running in the next couple of weeks. For my quote, I would like to present not something from my doctoral work, which was in Shakespeare in the Night Sky at the Hebrew University, nor would I like to say something from my master's work decades ago at Queen's University with Gerard Manley Hopkins. But this time I go back to my undergraduate work at Acadia, where I studied Henry David Thoreau, who lived in this little cabin by Walden Pond. And I'm quoting from his 1854 magnum opus from Walden. Both place and time were changed, and I dwelt nearer to those parts of the universe and to those eras in history which had most attracted me. Where I lived was as far off as many a region viewed nightly by astronomers. We are wont to imagine rare and delectable places in some remote and more celestial corner of the system, behind the constellation of Cassiopeia's chair, far from noise and disturbance. I discovered that my house actually had its site in such a withdrawn, but forever new and unprofaned part of the universe. If it were worth the while to settle in those parts near to the Pleiades or the Hyades, to Aldebaran or Altair, then I was really there, or at an equal remoteness from the life which I had left behind. Thank you, Diane, for letting me say hello to everyone.
Thank you, David. Let's see. Bob shared with us the SDO info. Have we got some more observing reports? We've had some clear nights. I know we've got to have observing reports. Riyadh's hand is up. Riyadh.
Yeah, a few nights ago it was a little bit clear. So what I decided to do is, because I didn't want to spend a lot of time outside, basically I took my binoculars and I started looking for very wide double stars. And that's something that I think a lot of people can easily do. There are all kinds of lists out there of very wide doubles that you could see with just a pair of binoculars. So that may be something that people can be interested in. And the nice thing about it is that some of them are really surprisingly wide. Normally, I don't look at very wide doubles. I I'm at the opposite end. I'm trying to separate as close as possible as I can. But some of them are wide enough that with a pair of binoculars, you probably can use the field of view to actually get an estimate on the separation. They're that wide. So try that and see if you can look at some separations, some very wide separations that way. Of course, with the binoculars, it makes it easier, for dimmer objects. Even though the separation is so wide that you should be able to see it with your unaided eye, you don't need any magnification. But they are dimmer stars. We're looking at maybe magnitudes in the 4 and 5 range. So binoculars would definitely help. So, but that's what I have. Thanks.
Thank you, Riyadh. Who's next?
I'll go.
All right.
And well, to share my observation, and of course I try to keep it short. As you know, I'll hit the road for just about anything, and I think you'll see some of what I saw when you look at the next issue of the WASP. So I won't share any images from there, but I would like to share something that I considered profound. Earlier, I was playing around with an image where I was saying, this is exactly what I saw. And then I looked at a few other images and said, no, I don't think the Milky Way was quite that bright when I looked at it. This is my approximation of the real sky as you see it. If you are in the UP, it's clear and moonless, and you're on Highway 123, about 45 minutes from the Mackinac Bridge. You can still see a little light glow. I actually have another image. If you turn left, this is another similar to real eyesight view with so of course when you image it and you do processing, you end up with this. So, but that was really interesting to me. My attempt at doing this at Tequamanen, I got there too late. So daybreak broke. There's what's left of the Milky Way as it's fading out and sunlight begins to appear. So I missed the opportunity to get this over to Tequamanen, but there will be more days for me to try again. So I did take this nice shot over to Tequamanen, daybreak. It's nice and peaceful there.
Yeah,
And
I'm
then,
jealous. I haven't been up there in 7
then,
years.
Yeah. So this is what one of the sides of the lower falls looks like. There's full on sunlight. Well, the sun hasn't broken yet, but my eyes are so accustomed to the darkness, it's like daylight to me. So then I ended up taking a couple of non-starry night pictures, and that's kind of what they look like. So go visit Tequamanen. There's Whitefish Bay. There's the sun blazing through. Go visit Tequamanen. Stop off at this Whitefish little park over here. Enjoy the sights and try to see some. These skies are basically around Bortle 2. They go between Bortle 2 and Bortle 3. So you will see some definition, just like in this picture, of the Milky Way.
How did you take those pictures, Adrian? How did you get those pictures?
I used a tracker. This is a 60-second. This happens to be a 60-second exposure on a tracker with one of my images shot at ISO 6400, f2.8. Fast lenses pull in night sky data when it's dark.
Oh, so that's a real picture.
Less light.
It's not really
Yeah,
that's a real picture. Yeah.
Yeah, this is a real picture. When you process it and you get something like this, you get the impressive looking, all the nebulae here, things like that. But I'm a little more impressed at what the sky really looked like. Well, that's not a good one right there. You get some duds. But yeah, that impresses me. When I look up and I see this, that's what the sky looks like. So that is the end of my observing report. Go up north, see some dark skies. Enjoy.
Wish I would certainly like to do that, eh, Jonathan? All right, any more observing reports before we go into in the news or in the sky? Throw up your hand, throw it in the stack. Make us jealous, Jonathan.
Well, I had a second hand. Actually, I actually had something to report for the Astronomical League this time, and that is that David Bransky has submitted a lunar observing program observation set. So I'm going to be sending that in, and hopefully we can get somebody else on the leaderboard.
Excellent. Is David on tonight?
Yep, I'm here.
Thank you, David. Great to have people participating in the Alcon leaderboard.
Thank you. Something to do during the pandemic evening.
Indeed. Yeah, and hoping to have a couple of bits tonight and in the sky that'll stimulate people to go out and look at the moon. So wonderful. All right, last call for observing reports. No takers? All right, then let us move into in the news. Share. Okay, in the news in the sky for March 18th. First up, can y'all see it?
Yes, we can.
Perfect, thank you, Adrian. All right, Oumuamua. There was a big debate. Is it a pancake? Is it a cigar? Well, a very intriguing new article, two of them actually have been published, indicating that Oumuamua may be cookie-shaped. So how does this work? Well, the team of researchers looking into it had a couple of the mysterious aspects of Oumuamua that they wanted to hone in on. One of them is that it did not have a vapor trail, and another one was the weird shape. So, the papers that were published Tuesday in the Journal of Geophysical Research Planets posit that it's the fragment of a Pluto-like planet blasted out of its home solar system about 400 million years ago, has been traveling through space, emitting nitrogen. So nitrogen ice worlds like Pluto and Neptune's moon Triton would sublimate over time. The authors compared it to a bar of soap slowly losing its shape in the shower, getting you this weird cookie sort of shape without leaving a visible vapor trail when it passed through our solar system. So it is a very interesting, pretty compelling Oumuamua hypothesis. And I'm hoping our interstellar object enthusiasts will jump on it. Oh, speaking of foreign objects, this beautiful thing right here is a carbonaceous chondrite that fell on the UK right before our last meeting on the 28th. We reported to you the story of the incredible flash it made in the sky, but as of this point, 300 grams of the meteorite have been recovered and taken to London's Museum of Natural History to be analyzed and studied. This is the first time since 1991 that any kind of space rock has been recovered in the UK. So the scientists there are very excited, even more so that it is a carbonaceous chondrite. So Sarah Russell, the professor who studies meteorites at the museum, says out of 65,000 known meteorites in the world, only 51 of them are carbonaceous chondrites whose fall was witnessed. So they are very happy to have this find. Russell mentions that this is the kind of asteroid that we have the sample return missions Hayabusa 2 and OSIRIS-REx visiting. So cool stuff. All right. It's been 2 months since NASA had an administrator. Jim Bridenstine stepped down back on January 20th. Word went out today that the rumors seem to be true. President Biden will tap former Senator Bill Nelson of Florida for the job. During his time in Congress, he was one of NASA's biggest fans on Capitol Hill. And in 1986, he became the second sitting member of Congress to fly in space as a payload specialist aboard Shuttle Columbia. Second sitting member because, of course, two spacefaring astronauts had already become U.S. senators by that point in time. Anyway, so that'll be interesting. He's got a lot of decisions to make, including, what to do about the timeline for Project Artemis and the moon. Speaking of NASA, we've got audio of driving on Mars. So NASA's newest rover, Perseverance, has recorded audio of itself squealing and crunching over the surface of the planet. It carried a microphone that was intended to record its landing, which apparently it didn't, but the microphone activated on the surface. And so we've got the first ever live recording of rover wheels banging and pinging and rattling as it rolls along. So it's a fairly alarming sound. One of the scientists did mention, if you heard your car doing that, pull over. But this off-the-shelf microphone has done the trick. And I'll post the link at the break. There is a 16-minute raw version and a 90-second edited version of these sounds from Mars. Speaking of Mars, if you saw a volcano, a really obvious volcano with a cloud streaming out of it, you would probably think that there's something going on with that volcano. It's live. Except this volcano, RCA Mons, is on Mars. Mars is very much not active, and the volcano is quite dead. So what is going on with this white streamer that has been measured at 1,200 miles or 1,800 kilometers? RCA Mons is the only low-latitude location on Mars where clouds are seen. It's the only one of the numerous volcanoes, some of which you can make out in this picture, in that region to possess this kind of cloud at this time of year. Well, fortunately, we have many spacecraft with their eyes on Mars right now, and the ESA has Mars Express. Mars Express has an orbit well positioned to cover RCA Mons, and it's seen this streamer growing and fading on a daily basis through the spring and summer. Well, so Mars Express teamed up with the other craft, MAVEN, Mongolian, Viking 2, Mars Reconnaissance Orbiter, to, basically put their digital heads together and figure out what's going on with this thing. It turns out that the streamer is what is called an orographic cloud. It forms as a result of wind forced upward by topographic features. In other words, wind goes up the mountain. The mountain perturbs the Martian atmosphere enough to trigger the formation of the cloud. Moist air goes up the flanks, condenses, and then comes back down. And it's a daily cycle that repeats every morning for several months. However, again, the ESA's orbiter is well positioned to note this. Many other craft cannot see this area of Mars until the Martian afternoon, so they miss it. Anyway, Mars has a lot going on, but this is one of the weirder ones. All right, imagine a supernova remnant in the sky stretching out this 90 times the size of the full moon. I'd say you don't have to imagine it because it's real, but you do have to imagine it because this thing can only be seen in X-rays. Huinga, as it's been called, was discovered by the new E-Rosita telescope, an X-ray instrument on board the Russian-German SRG satellite. It is 25 times more sensitive than its predecessor, Rosat, so the team of scientists anticipated that they'd find previously undetected supernova remnants, but they're really happy they found one this big, less than 2 years into the mission. So Huinga, which you can see in the picture up here, it's been named for the medieval name of the hometown of team leader Werner Becker of the Max Planck Institute for Extraterrestrial Physics. And if you had X-ray vision, it would take up 4.4 degrees of sky. All right, well, you can't see that, but what can you see over the next couple of days? First off, in brief, we are on the cusp of the March equinox, so spring for us, autumn for our comrades down below the equator. So March 20th at 5:37 a.m. Eastern Daylight Time, the sun will cross the celestial equator, and we will start seeing much longer days. Speaking of crossing, this is a good time to see the lovely feature on the moon called the lunar X. So for a few hours during the first quarter phase, the lunar X becomes visible in strong binoculars like my beloved 15x70 Celestrons and backyard telescopes. So when the rims of these craters here, Purbach, Lacaille, Blancanus, are illuminated from a very specific angle of sunlight, they form a small, remarkably clear X shape near the terminator. The X is going to have peak intensity 6:30 p.m. Eastern Daylight Time this Saturday, March 20th. Waning daylight for those of us in the Eastern Americas. So take a look and, don't point your instrument at the sun. Also on the moon is something that I did not remember and I need to look for. Wednesday night, March 24th, the terminator, that line dividing the light from the dark, will fall to the left or lunar west of the Bay of Rainbows, Sinus Iridium, this beautiful little semicircle here in the Ocean of Storms. And the golden handle will be visible. Golden handle is produced by slanted sunlight brightening the eastern or right-hand side of the Montes Jura mountain range, which is the old crater rim. Anyway, so Sinus Iridium is almost craterless, but it does have some nice details. So again, March 24th, check out the golden handle of the Bay of Rainbows. And finally, this one will be a bit easier. Aldebaran, the bright red star in Taurus, is called the Eye of the Bull. The bull will have two eyes tonight through the 22nd, more or less, as Mars will basically enter the face of Taurus the bull. It will outshine Aldebaran only slightly. The colors will be quite similar. And the closest they'll get is 7 degrees. So Mars will be on the upper right. And that is definitely worth stepping outside on a clear night to check out. And that is in the news and the sky until we convene again in April.
Yeah, drive safe when you're looking at Mars and Aldebaran, because you don't want to be staring at that too much when you're behind the wheel of a car.
Indeed. All right. Any more questions, comments, or anything like that? Or we'll let y'all go for a 20-minute break and reconvene at 8:30 with the main talk.
Diane, what time again was that Lunar X? I've been chasing that for last couple months.
Lunar X is going to be best at 6:30 p.m.
6:30?
Yeah,
right.
prior to sundown.
Yeah,
If you want
there's
to chase the Bay of Rainbows, it's going to be good all night on the 24th. But X will be best 6:30 p.m. on Saturday.
Yeah, I know that there's also a Lunar V that's a little further up. And if you catch it right, you catch both letters on the moon at the same time. The V is a little further north, but that X is, I've been going after the X and missing one way or another the last couple of months. So I've written down that time so I can see if I can catch it. So thank you for that.
You're welcome. Happy observing, everybody. We all
I do have an asteroid picture I wanted to show.
Yes, please.
Go ahead, Doug.
Okay, you see that? On March 4th, I captured asteroid Apophis one day before its closest approach to us, this pass, which was about 10.5 million miles away.
Very cool.
It will pass by us again in April of 2029, but will only be, I think it's less than 20,000 miles away. So 2029 will be a very close approach, but this one is 10.5 million miles. This is on the evening of March 4th.
And for those of you who don't know the fearsome reputation of this object, at one point it was predicted to be having a very close call with the Earth, so everybody got obsessed with it as being a planet killer. We now know it's not going to do that, but very cool. Thank you for sharing that, Doug.
Okay.
Actually, Diane, we did some asteroid belt observing, although some might say that we observed a dwarf planet rather than an asteroid. But
Oh yeah, that was between the last meeting. Yeah, tell us about our Vesta adventure.
I mean, we looked at Vesta.
Yeah, we looked at Vesta. We had never seen Vesta before that we know
It
of.
was, I think we actually did see it on the beach up north about 10 years ago, or maybe 12 years ago. But it was hanging out in a very easy to locate spot. It was one of the only bright objects near it, and so it was pretty easy to single out and get the geometry of the stars and find the one that wasn't a star, and it was pretty cool.
I did get another asteroid that same night, but that was a nice bright one.
I hear a weird kind of scritching noise.
I had somebody asked me a question about that they were observing somewhere. I don't remember exactly where they were observing, but they said they saw a light flash, and then a few minutes later in the same place they saw a light flash, and it seemed too far away for a plane, and it certainly wasn't moving. And I said, what could that have possibly been? And my thought was perhaps, and I don't know whether any of you can verify this, but it could have been a satellite that was in geosynchronous orbit, which was perhaps catching the reflection of the sun or something like that momentarily. Has anybody ever seen anything like that? That would it just doesn't move because it's in geosynchronous orbit. Has anybody seen that at all? Some of you guys that are observing, ladies.
I see geosynchronous orbits all the time.
Okay, so the point was that I kind of thought that would have been it, if he saw it repeatedly. He said he saw it for about over a period of about 5 minutes, and it really didn't move. So that was my kind of a spin. That probably might be right. I don't know.
In fact, you shoot into Sagittarius, that area, big, fairly wide field, and turn your clock drive off, and you'll see stars going by, but the satellites will be sitting there in the frame.
Really?
Take 5 minutes. They don't move.
Uh-huh. And catching reflection, I guess, would be the reason for it.
Yeah, it's far enough out.
Okay, and then I probably gave him the right information. All right, thanks.
I went after a Eunomia that same night. I'm going to share this just for grids. And I'm going to flash it back and forth. You'll see the motion. I did a plate salt on it as well, but there it is. 10 minutes apart, this one to this one. See that? See how it moves?
Yes. Cool.
So that was the same night I was working asteroids.
Very nice. All right, good stuff. Thank you for everybody for taking advantage of the surprisingly clear weather we had. I'd like to give you all 15 minutes to take a bio break before we ease into our orbital mechanics. So see you all in 15.
It's going to be clear tonight too for the weekend. They're doing right now. Yeah, it's playing here. Yeah, it's moved up. Bill's up his headlight, calling into the meeting. I can tell where he's at.
Oh my God.
Welcome to Kerbal at night. David, my friend, it's good to see you. I hope you enjoyed some of the night sky photos from my latest adventures. I have to get to Arizona one of these days.
And I certainly look forward to your next visit. This is not a good time to come to Arizona. We're at the very tail end of the pandemic, but even we aren't able to observe much because of the observatory maintenance going on right now. But I'm out there a little bit and using the telescope, the 16-inch, right out under the sky like it was originally built for.
That's cool. So my plan is to head to the border of Oklahoma and Texas. A group of us from the lowbrow astronomy group are planning in hopes that, of course, we are much further along and near the end of the pandemic, or we can safely observe. We want to go to the Oklahoma, it's called the Okie-Tex Star Party. They have it, there's a campsite that is, I guess, near the border. It's actually near the border, western borders of Oklahoma and Texas, not far from New Mexico. And both some of the darkest skies that are in the United States. So I'm going to go find
I agree with you. They are very dark.
I will be putting them to my test, but I expect I will find a lot of happiness taking some nightscape photos out there. I'm looking forward to it, and I'm looking forward to making sure my batteries are fully charged when I go, or that I have adequate power to take all of the frames that I'm going to want to take.
Well, good luck. I hope you'll have some really good dark sky to be observing under.
Yeah, the one I will actually use a telescope instead and attempt to observe some things that I would normally not be able to see in the skies back home. So I'll be using my eyes as well as the camera sensor.
That's very smart to do. Looking forward to seeing what you get, and I hope you have a good visit. Let me know when you're about to leave.
I will.
Yeah.
Yep, I have to decide if I'm going to drive with the caravan or if I'm just going to go solo trip, where I'd be able to stop and take photos along the way. So I'm thinking joining the crew is going to make it a lot more fun. I don't know, Doug, you're there. You ought to be on we've got a Camp Lowbrow group now. I don't know if you followed along in the email.
Yeah, I've been watching it, and I may be going down there. It'll be my first visit to Okie-Tex. I've been to Texas, the Texas Star Party 3 times, but I've never been to the Okie-Tex. That's in October, right?
Yeah, it's October 1st through 9th. They're hoping they can pull it off. The website hasn't opened up registration yet, but they're waiting to see what they're going to be able to do.
Yep. I just got signed up for my first shot, vaccine shot on Saturday, coming this Saturday. So it looks like once my wife and I are vaccinated, we can break out a little bit.
Yeah. I think on the 5th here in the state of Michigan, April 5th, it's going to open up. And I've got a few people. I've got one person in particular who's, I think, waiting and watching to get me signed up. I think my wife wants to be one and done, but I may convince her that it doesn't matter what vaccine you get as long as you get something. She's being scared by the reports of the side effects after the second vaccination. So I have to try and counter with the idea that the side effects of the virus are far worse than the side effects of any vaccine.
Let's put it this way to you in the best way that I can. I've had both shots. I had absolutely no effect from either one of them, the first one or the second, the Pfizer. I actually did a 15-hour tournament on the Saturday following the Friday shot. Nothing to worry about on that. Let's put it this way. For those that are afraid of the shot, if you don't take it, if you take it and it doesn't work, you're right where you are right now. If you take it and it does work, there you go. The issue with the shot is it will save you from dying, and that's what it's all about. So that's all I got to say about it, and I'll say it. All right.
Yeah, like I said, I have to, that there is the virus dodger and the mask dodger community. It's an interesting phenomenon. But there you have it.
Adrian, there are two things that are universal: hydrogen and stupidity, and I'm not that sure about hydrogen.
Just to add my 2 cents in, I had both shots too of Pfizer, no problems at all.
Not at all. Nothing.
I'm not worried about it. I meant to bring it up to say, well, it'll be free probably to go up to some star parties.
And as far as the mask is concerned, one more thing: if you just breathe only out of your mouth, you just have to cover your mouth. If you use your nose at all, you got to cover it over your nose. And that's people don't seem to get that part either.
All right, guys. Lively discussion, good stuff, but it is 8:30 p.m. and I'd like to call the meeting back to order so that we can have our feature presentation of the night. And to introduce tonight's speaker as ever, I will give the floor to Dr. Dale Parton, the program chair.
Okay. Thank you, Diane. Tonight, our short presentation, I'm sorry. It's not our short presentation, our only and main presentation. It's going to be given by our own Bob Trembley. I did a little research on Bob. He joined our organization back in late 2011, almost 10 years ago. And of those nearly 10 years, this is his 7th year serving as a club officer. Pretty impressive. He served as publications chairman for 2 years. And then this is his 5th year serving as outreach director. He did 2 years, was term limited. Now he's doing 3 more years. So he really has contributed to this organization a lot in his 10 years with us. He has various astronomical interests, including asteroids and near-Earth objects. But the thing I've seen him really display interest in the last couple of years is space-related computer software, including virtual reality goggles that he has demonstrated, where you can fly around the solar system and so forth. He had that out at Stargate at once or twice at least. He and his wife Connie are both solar system ambassadors. She's a middle school science teacher, if I get it right. And they run an after school astronomy and space science club at Connie School called Endeavor Space Academy. I wish I could have been a part of one of those when I was at that stage in school. And more recently, I think, Bob also works for the Vatican Observatory Foundation, doing a whole bunch of different jobs. He can mention a few of those if he wants to. And his presentation tonight is entitled, sounds scary, difficult, challenging, but I doubt it will be, basic orbital mechanics. Bob?
Hi there. Can you hear me, first of all?
Yes.
Okay, cool. Hi there. Thanks for the intro. So I'm going to get my co-pilot out of here because he is no help at all. So I said I did not start out to learn orbital mechanics. It just kind of happened. And well, let's just go along the way here. So orbital mechanics, so objects in space move and react quite a bit differently than us permanently bound earthbound humans might expect. The math, involving objects on the surface of the Earth simply do not apply to objects in space. So there's some math. I know everybody loves it. So orbital mechanics is at its heart nothing but math, very little of which I actually understand, none of which I'm going to be explaining to you. I just wanted your eyes to pop out a bit at some of the math. So if you're learning orbital mechanics from a strictly mathematical viewpoint, it's understandable that it might take a long time to understand and learn it. That's why I'm going to use visuals in the simulator. This graphic, some of you might be familiar with the comic XKCD. This is absolutely very true. If you play Kerbal Space Program, which I'm going to be showing you, you will learn orbital mechanics without even knowing you're learning it. It's just amazing. So I've played much longer than 4,100 hours because there's an educational version of it with a whole bunch of physics demos and stuff in it. So yeah, I've logged thousands of hours in Kerbal Space Program, and it's marketed as a game, but it's honestly a 3D space and physics simulator that plays like a game. So I've laughed, I've cringed, I've been astounded, I've been frustrated at failures and determined to fix them. So it's great for learning engineering and fixing problems, and great. My after school club, the kids loved this thing. So NASA and the European Space Agency have partnered with the developers of Kerbal Space Program, and there are recreations of real life missions built into the game. So that's really cool. So let's talk about gravity. Objects in space generally have mass, and they are drawn towards each other in a predictable manner based on how massive they are and how far apart they are, because of math. So you can't have orbits without gravity. Just not happening. So you might have seen fountains like this. The path that water stream takes, or a ballistic artillery shell, follows a very predictable path based on math, which I'm not going to be explaining. So Here we see all of these trajectories are impacting the ground, and that would be a suborbital, and well, we want to get into orbit. So when it comes to the space program, let's assume you don't want to hit the ground. So how do you miss the ground? Well, Newton's cannonball was a thought experiment Isaac Newton came up with. He visualizes a cannon at the top of a very high mountain. Now, if you have no forces of gravitation, no air resistance or anything, and you fire the cannon, it should go straight and keep going forever. If you have air resistance or if you have gravitation, then the cannonball will follow a different path depending on its initial velocity. Okay, if the speed is low, like we showed with the artillery shells and stuff, they'll fall back to Earth. And that's suborbital, and that would be the labels A and B there. If the speed is higher and if its orbital velocity, it will go into orbit at that height, and that's the label C. If the speed is higher than orbital velocity, but not high enough to leave the Earth, then you're in an elliptical orbit, and that's labeled D. And finally, if the speed is very high, it will leave Earth in a parabolic or hyperbolic orbit, and that's path E that you see on that graphic. So, how do you miss the ground? You have to throw your payload really, really hard. I missed the shuttle. So you also need to get above the atmosphere. Sputnik was barely above the atmosphere. The International Space Station and Hubble are above the atmosphere. Objects below about 99 miles will experience orbital decay due to atmospheric drag. Another name for that is called aerobraking. So what is an orbit? Okay, gravitationally bound trajectory of an object around a star or a natural body, normally repeating, although it doesn't have to be. Generally, its orbits are ellipses. Circles are ellipses. They orbit the center of mass of that body. So that is not an orbit. I'm not sure what that is. It would take a lot of energy to maintain that. So back to some math stuff. And geometry. Orbits can be thought of as conic sections. And there's some of Kepler's equations, which I'm not going to explain to you. So here, circular orbit, probably what most people think about when it comes to an orbit, basic circular orbit. In this graphic, you're looking down the North Pole, and the satellite is orbiting or following the right-hand rule. There's your elliptical orbit. If you pushed a little bit harder, there's your elliptical orbit. And you push really hard, you'll be in a hyperbolic or parabolic or hyperbolic orbit. Now, Diane mentioned Oumuamua. That was on a hyperbolic orbit, and I looked this up. I didn't know there was this many interstellar visitors here. I knew about the first three, but there's several of them I didn't know and hadn't heard about, and I'm wondering why I hadn't heard about those. So that's pretty interesting. So geosynchronous orbit, this is an orbit where the orbital period equals the rotation of the body. The eccentricity, which means how wide the orbit is ellipse-wise, and inclination aren't necessarily bound to any particular values. Generally, you think of a geostationary satellite. This one, inclination is 0, eccentricity 0, it's a perfect circle, always stays over the same spot on the planet, and your satellite dish doesn't have to move to look at that thing. So here's a hurl-worthy example of a geostationary satellite, always over the same spot. I'll get rid of that because that is hurl-worthy. So there are some bizarre orbit types. And again, I learned this from Kerbal Space Program from a mission where I had to put a satellite in one of these orbits, and I didn't even know these things existed until I played this game. So this is I believe that's pronounced Molino orbit. Now notice the name of all those vessels down there, Cosmos, those are all Russian vessels. Here's a tundra orbit, similar but different, highly elliptical geosynchronous orbit. Now, there's a lot of vessels that are in polar orbits. These, a lot of Earth observing climate satellites, lunar reconnaissance orbiter, Mars reconnaissance orbiter. What it is here's your body, and you're orbiting around the pole like that. The body rotates underneath it, and so you'll cover the entire surface of the body over the course of days or weeks or whatever. So you can do monitoring on that. There's a whole bunch of satellites that are orbiting the Earth like this or slightly away from 90 degrees. A sun-synchronous orbit, a nearly polar orbit in which the satellite passes over the given point at the same mean solar time of the day. OSIRIS-REx orbited Bennu like this for quite some time, and it always kept facing the sun. And if you'll remember, Bennu was spitting out particles, and they didn't know if there might be an emergency and they had to get away. Well, when it was in this orbit, all it had to do was accelerate toward the sun because it always knew where that was and it could get away from the asteroid really quickly. So orbital directions are going right-hand rule. Taking a look at the image on the left here, right-hand rule, we've got a spacecraft orbiting in the direction the planet is rotating. That is called a prograde orbit. If you're orbiting in the opposite direction that the planet is rotating, that is a retrograde orbit. Closest point to the object being orbited is called the periapsis. The furthest point is called the apoapsis. Those are actually generic terms for apsis. You might have heard apogee, perigee, that's Earth, but the moon has apolune, perilune, apogee, perigee for Jupiter. Stars are apoastron and periastron, so only a few bodies have those custom apsis names. So when you're in orbit, I've shown you orbits that have no inclination. They're orbiting right around the equator. Well, you can order 90 degrees or any inclination you want. Inclination is simply the angle of the orbit that differs from the equator of the object being orbited. So the International Space Station orbits at 51.63 degrees. Why? Well, so NASA and the Russians, when they negotiated the IIS, it was more economical for the Russians to launch from Baikonur, so that's what they did. And launching at 51.6 degrees ensures that they don't make China angry. So Russia was doing a lot of our launches, and so that's where we launched from. Now, this was brought up. Kinetic energy. When you talk about orbits and changing orbits and stuff like that, it's all about your delta V. This was brought up at Astronomy at the Beach, I think a couple of years ago at one of the lectures. I was at a science fiction convention, and one of the lecturers said this. He said, everything in space is moving really fast compared to everything else in space. Remember that, because that is true. In order to get from place A to place B in space, you have to change your velocity. Usually quite a bit, and that's delta change in velocity, delta V. So how do you accelerate? Well, point your nose forward, kick the engine on, and you're going forward. Now this is delta V, excuse me, is a measure of the impulse needed by a vessel to perform a maneuver. Okay, thinking in simple straight lines here, this vessel is at rest compared relative to you, and it applies an impulse, changes its velocity 200 meters per second relative to you, and now it's going 200 meters per second. So if you want to slow down half that velocity, you have to flip your butt around and point your engine in the direction you're going and thrust for like half the time, and that would slow you down for half the speed. This is how you slow down. Now, space is 3D. Again, you're not in Kansas anymore. You have 6 directions you can maneuver relative to your current position in space. So this is what a maneuver node in Kerbal Space Program looks like. A maneuver node is simply a point in space and time along your current trajectory that you're going to apply an impulse to the spacecraft. And I love the fact that this OSIRIS-REx scientist says he always envisions maneuver nodes like Kerbal Space Program, and I'm going to be cursed for the same thing. There's no way I'm ever going to be able to see a maneuver node without thinking of it this way. So raising your orbits. This is where it gets weird. Here I am. Here's a maneuver node, my rocket. I am pointing in the prograde direction. I'm orbiting prograde. I'm pointing prograde. If I kick the engine on, you draw a line. My pointer on here. You draw laser pointer. There we go. Okay. So I'm orbiting here. I'm pointing this direction. I'm thrusting this direction. Draw a line through your maneuver node, through the center of gravity to the other side of your orbit. That's what gets pushed up, not where you are on the other side of the planet. It's crazy. So that was one of the first things in Kerbal Space Program. Is just you're looking at going, is that right? But again, you're not on the surface of a planet anymore. So in order to raise your orbit, you thrust in the direction you're orbiting. And Brother Guy wanted me to make sure to mention that when you apply an impulse to a rocket to raise its orbit, you always return to the point at which you applied the impulse. He said in all the years, only one professor ever mentioned that. So I'm mentioning that. So again, here, if I raise my orbit here up to my new apoapsis, I'm going to come back to the same point that I applied that thrust. So interesting point. So your orbital speed at your periapsis, the closest point, is going to be faster than your speed out at your apoapsis, your farthest point. Essentially, what's going on when you're up at your high point here and you're coming back down, you're falling down the gravity well. So you're going to increase speed until you're going fastest down here, and then you're going to slow down as you go back up. So to circularize your orbit, when you think of raising your orbit, you can't just do it in one maneuver because you raise it on one side, then you get over there, and then you raise it on the other side. So it takes two maneuvers generally to raise your orbit. Now, if you've got an ion engine doing a low thrust, then you can have continuous stuff. But if you're using a big engine, you got to do two maneuvers. So there's an effect that was discovered by Hermann Oberth here. He discovered that if you do accelerate at your periapsis there, you get a little boost for fuel efficiency. And the Indian Mars orbiter mission actually used this. It boosted its orbit several times at the periapsis until it eventually left Earth orbit and made its way to Mars. So lowering your orbit, again, you turn around and you thrust in the direction that you're going, and that will take your far point and shrink it down. If your apoapsis ends up inside the atmosphere or inside the planet's surface, you're on a suborbital trajectory, and that's how you land or crash. Plane changes. Changing your plane of your orbit is an aspect of orbital mechanics that is one of the weirdest things ever. Okay, so the blue line here is my current orbit. Now let's say I want to tilt my orbit that way. Now, you don't point your rocket forward, you don't point your rocket backward, you point it up or down, and that tilts your orbit on a line through your maneuver point through the center of gravity. So that's really weird. It's really weird to see. Maneuvers like plane changes are really expensive the closer you are to the body being orbited. If I did this plane change way out from the Earth, it would cost a lot less fuel-wise. If you did it this close, it might take more fuel than you have. Sometimes it's more efficient to launch a rocket into the correct plane than it is to change it once you're already up there. Again, it's all about fuel and fuel expense. So the other thing you can do, the other direction that I haven't covered is pointing yourself toward the planet or what you're orbiting or away from it. And what that does is instead of shrinking your orbit or anything like that, what it does is it just curves it around the maneuver point. So coming back from the moon, when I do this, I use this maneuver to fine tune where I hit the top of the atmosphere for reentry. Now, talking about how now this was misused and lost in space. The new version of Lost in Space, Maureen Robinson tried using the "I'm driving the deadlier weapon" scenario and pointed the Jupiter 2 at the planet and floored it. Well, she's not going to hit the planet for a real long time because her orbit's just going to rotate around like that. It would have been more effective for her to point retrograde, burn that until her orbit's really thin, and then do it. But who's going to know that? So, ruin some science fiction here. I saw that. I saw her floor it, and I'm looking at it going, that's not going to work. But who's going to know that? So, Hohmann transfer orbit. This is the way to get, it's a way to get an elliptical orbit used to transfer between two circular orbits. So, what I'm showing here is I am in the same plane as the moon, and this is showing me thrusting at a maneuver node at the particular time to get my apoapsis out to where the moon is going to be. You don't thrust at the moon, you thrust it where it's going to be. So this uses the lowest possible amount of propellant again. And like I said, when I saw The Martian, they mentioned doing this. So again, there's a lot of math and some math involved there, but he published the math for this transfer orbit in 1925. Now, some of you may remember this movie. It's actually the first science fiction movie 2 decades beforehand. Depicted a trip to the moon. Several people piled into an oversized bullet, got loaded into an enormous cannon, and got shot at the moon. I'm not exactly sure where they were aiming that big cannon. They were incredibly lucky to actually hit the moon without having the math first, but they did hit the moon. And they did so without decelerating first. Now, we're not talking 2 Model Ts having a fender bender here. That bullet's traveling several kilometers a second. There's going to be a big crater where that hit and not much else. But don't worry. The passengers in the bullet went from 0 to several kilometers per second nearly instantaneously, so it's doubtful their bodies maintained structural integrity after launch. So great, I've thrown shade on the first science fiction movie there was. Okay, well, whatever. So you can, once you get to another body, again, you're in a parabolic or hyperbolic orbit around that body. And you can fly by that body in 2 different ways. You can fly by in the opposite direction that it's orbiting. And that depending on how you manage that how close you are, that can give you a kick. In this instance, I'm showing you coming back to the Earth. This is how you do a free return trajectory. This is a trajectory of a spacecraft. After you have done your initial impulse at your maneuver node, you'll fly by your target and come back. And in this case, I actually have it entering the Earth's atmosphere. So 1 impulse, and you do a flyby and a return. So that was here. This is flying by retrograde. Generally, this will keep you pretty close. You'll lose some energy. Again, depending on how close you are, I can actually pick up some energy from that moon. Now, if you fly by the opposite, if you fly by in the direction that the body of the moon or the Jupiter or whatever is orbiting, then you can pick up a lot of velocity. It can actually kick you right out of the system you're in. You're right out of the sphere of influence of the planet you're in. Now, the first time this happened to me, I asked myself, well, okay, so I've gone into the first sphere of influence of the moon, then I left it, and now I'm leaving the sphere of influence of the planet. Where am I? What sphere of influence am I going to be in? Well, I should have known that. It's the sun's sphere of influence because it's one gravity well to rule them all. So yeah, the sun's got a giant gravity well, and if you've never seen this, you should go see that XKCD thing and look at it because it's really, really cool. So I've talked about our currently I've talked about thrusting and getting to places using our current level of technology. Now, I've talked a little bit about some science fiction. Now, if you're a fan of The Expanse or a lot of science fiction that has, you know, ships with energy to spare, these things, what they generally do is they, I don't know if I can pronounce this right, Bacistochrome. It's essentially you fly at 1G, so you're comfortable in the ship, and you accelerate at 1G continuously until you reach the midpoint, and then you flip over and you decelerate at 1G. This is how they did it in The Expanse. But again, this requires ridiculous amounts of spare energy and delta V. So we're not doing that yet. But in The Expanse, it was interesting to see the orbits plotted that way. I wonder if they actually did the calculations and that's what they would look like. So wait. So before I get into the live demos next, I wanted to mention, I just wanted to mention that. So flip and burn. So live demos. So I am going to flip over to Kerbal Space Program now. Let's get out of that. Stop sharing that for a second. Right. Share. All right, so this is Kerbal Space Program. All right, so the first thing I wanted to show you is some of the things that, this is how I learned a lot of the orbital mechanics and stuff, but there's the asteroid redirect mission. These are the missions that they partnered with NASA before they canceled the asteroid redirect mission, but they are in the game here. And there are some, there's more scenarios there. Cancel, there's the mission. These are the missions. They did the Rosetta mission. They partnered with the ESA, so there's Rosetta and Bepi Colombo, and you can put these things into orbit around Mercury. It's pretty darn cool. But let's get out of here and go into my WAS orbital mechanics. So I've shown you a whole bunch of mind-blowing things here. Now I'm just going to demonstrate them and show you how these things work. As soon as it comes up. All right, the very first thing I'm going to show you is launching of the Orion. I'm going into the vehicle assembly building here. That's the big cubic building, modeled to look like the one at Kennedy Space Center. This is actually, I did not build this rocket. I downloaded it from a sharing site. Somebody else built that. This is a model of the Orion. I'm going to demonstrate getting into orbit with this. Yeah, so let's go up to 400 kilometers. There we go, and there's my three Kerbals. Now these are Kerbals. If you've never seen them before, they're kind of like a cross between Frankenstein's monster and Minions. I have a feeling it's because when you kill them, and you will kill them, you don't feel as bad if it was a human. So I've got time acceleration on here. That's very important in this game because, you know, getting to other planets can take years. Like I have a mission going to the Jupiter equivalent in this planet right now, in this mission, and it took 2 years to get out there. So you got to time accelerate. So there you're starting to see some drag effects, some atmospheric drag. And notice the plume is starting to get bigger and bigger. This is a mod which models what it actually looks like in the atmosphere. So I'm high enough now that the atmospheric drag has gone away. Over here, you see my fuel of my solid fuel boosters is almost gone, and there they just kicked off. So now I can kick off the escape system here. All right, so now I'm pretty much on autopilot. So yeah, this is why I want to time accelerate on, because it takes about 10 minutes to get to orbit, and I don't want to do that. This is inside the rocket. Shook all over. There are mods where you can actually fly this thing entirely from the cockpit. I'm too scared to do that. So here I am, and I've been thrusting for a long time. You might think I'm up pretty high. Well, I'm not actually. Let's turn the rest of these guys off. Just me. There we go. So this is my apoapsis. This is my high point. I don't have a periapsis yet. My periapsis is inside the planet. So it's starting to get higher and higher here. It starts bending around on the other side of the planet. And then once I get up to 70, so now I am still suborbital here. My periapsis is within the atmosphere. My apoapsis is 400 kilometers up. So here I am. So what I'm doing now is, let's ditch that section. I am getting into the position I need to be in for my maneuver. And what I'm going to do is I am going to coast up to my apoapsis, my high point, right there. Go. Time accelerate. And now you'll notice when I get there, I'm in the right position. And I'm going to raise the orbit on the other side of the planet here. So there's my periapsis, my low point. If you're perfectly circular, your periapsis and your apoapsis will flip halfway between. Like that. Doink. So there we go. I'm in a perfectly circular orbit with my Orion craft. So let's go to some of the other stuff I wanted to show you. There's my International Space Station at 51 degrees. And I've got my my Dragon crew capsule. So switch over to that. This thing needs to get to the International Space Station. So I'm going to demonstrate orbital rendezvous and docking. So this is going to require plane changing and doing a Hohmann transfer like I showed you. So my engine is on. So the first thing I have to do is I have to set the ISS as my target. So the problem is here. Let's get rid of this guy. I've got a lot of stuff up there. All right, so I'm in the wrong plane. All right, I'm in an equatorial orbit here, 0 degrees inclination. I need to get to 51 degrees. That is going to be horrendously expensive. Let me show you how horrendously expensive it is. So what I need to do is I need to match planes with my target. So there's my maneuver node, and you do the maneuver at the point where the two planes cross, right, like that. So that's where I'm going to be flipping my plane, which makes sense. If I flip it over here, it's going to be in the wrong plane. So now you'll notice the red area here. This plane change is going to cost more fuel than I've got in this thing. So with a simulator, you can cheat. There's infinite propellant, infinite electricity. Now I can do whatever I want. So let's execute this plane change, and you're going to watch this plane change happen. First thing you do, get into the position you need to be in, and there I am, pointing upwards. So here I am right here, coming around to my maneuver node here. Slowing down. Come on. There we go. Now, it's going to take me 2 minutes to do this burn. Now, you'll notice I started way over here. What happens is that's the halfway point. There's 1 minute to my maneuver node, 1 minute past. If you've got a long burn, you burn halfway on either side of your maneuver node. I wonder if I can accelerate this because this is going to take a while. So you can see there's my plane starting to change. I am going to time accelerate this. So this is my plane flipping. Now, frighteningly, you'll notice I'm suborbital right now. But as this flips around, this will come back out. It's just weird seeing it thrust that way. So there's, like I said, starting to come back around now. Boy, I should have put a bigger engine on this thing. All right, so the planes are almost the same. We're gonna need to do another plane change there. All right, so now I'm gonna turn the autopilot on. Rendezvous autopilot. And just let it go. So it's going to fix my plane. What's it going to do here? It's going to match my plane because that burn took too long. Should have put a bigger engine on this thing. Yeah, this is not going to take any time at all. So like I said, this burn took so much fuel, it would make more sense to launch this into this orbit to begin with. So now my plans are the same. And what I'm going to do now is a home in orbit. As soon as you're done thrusting, there we go. So what I'm doing here, there's my maneuver node. And it's going to pull the far part of my orbit down to this point, and that's where those two are going to meet. Earlier this morning, I made the mistake of putting the space station up first, and then the crew capsule right in the same orbit. They smashed into each other. My space station blew apart. It was very embarrassing. Okay, so now I've pulled that part of my orbit down, and that is the point where I'm going to meet up. So now it's instructive to see it from this viewpoint. It's my space station. There's my space station. Oh no, what is going on with my space station? Well, that is not what I wanted to show you, but wow.
That's for your space program, Bob.
You warned us the little guys get killed a lot, Bob.
Oh my goodness. That would be called the Kraken because this was working fine before. Oh my goodness. Well, if you've ever seen the movie Gravity, this is a very good description of what's going on there. Okay, I won't be showing you. You can stop trying to autopilot to that because that ain't working.
What happened?
I think what happened was I was thrusting too close to it, and the exhaust did that.
Oh my gosh.
Elon Musk's satellite.
Oh my gosh, I can't
Open
believe
the
it.
pod bay doors, Hal.
Oh, speaking of pod bay doors, Hal, let's show you something that's not embarrassing and explodey. So, remember I said I sent a mission out to Jupiter. Let's get out here. And actually, let's go back to the Space Center.
Seems like you would have been fired by now.
Yeah, well, I think that was an instance of the Kraken, and that was not supposed to happen. Maybe I should have used a smaller space station, but those solar panels were like flapping all over the place, and they shouldn't have. Ought to been. All right, so Discovery. There we go. Let's fly the Discovery. This is a mod. The ship components here are from a mod, so this is not part of the standard game. But it was appropriate to send this out to Jupiter. Anybody recognize that? So I have this thing on the way to Jupiter right now, or Joule in the game is the Jupiter equivalent, and it is already taken 2 years to get to this point, and it is a year from coming into the Jupiter sphere of influence. So space is big. So this is what I have it doing. It's going to fly by Jupiter. And notice that if I do nothing and have this thing fly by Jupiter, notice how huge my orbit got here. That's again, your gravity assist. So what I wanted to show you here is, let's just take you into Jupiter. Right to this point right here. So here I am, going as fast as I possibly can, and I'm coming into Jupiter. So again, when you get out this far, things move very, very slowly. Now, in Kerbal Space Program, since I have time here, it's about 1/10 scale of our solar system. This was because of restrictions to the graphics engine and playability. If they'd made the Earth the actual size it was, it would have taken too long to get into orbit, been too difficult, and you're going to lose the interest in the people playing it. And scaling it down made it work better with the graphics engine and made it a little easier to play, and you can still learn your orbital mechanics that way. So again, I'm coming into Jupiter here. Now I am cruising. Look, I am going really, really fast. I'm interplanetary speeds. When I finally get into Jupiter's sphere of influence here, I am still going to be going that interplanetary speed. So here I come. That is where I intercept. Now, I don't know if you have seen the movie 2010. They come into Jupiter and they send a probe down to Europa. Then they do this really exciting aerobraking procedure around Jupiter. Here's the problem. They do the aerobraking after they send the probe down to Europa. So I am just about to the point where I can send my probe down to Europa. Now the problem is here, I'm still going interplanetary speed. So this probe that they sent down to Europa is going to be going right by Europa. And after I started playing Kerbal Space Program and seeing this, I said to myself, well, yeah. Now the other interesting thing is the first time I ever sent a probe out to Jupiter was when the Juno probe went out to Jupiter. And you'll notice here, my periapsis, I am 59 days away. I am 2 months away from my periapsis, even at the speed I'm going. That's pretty much what the Juno probe saw. It was the gravity well of Jupiter is gigantic. So you, again, if you're going to send a probe down to a planet here, you're not going to want to do it at these speeds because you've got to slow down. So let's show you slowing down. So these things, I didn't know this anyway, but these are nuclear engines. So, and I don't recall this guy ever slowing down at Jupiter. I just saw it going into Jupiter. But no, you have to slow down, and you have to slow down at the periapsis. So let's do that. I'm going to create a maneuver node right here at the periapsis. And what I'm going to do is burn retrograde, which means point my butt in the direction I'm going and pull it back. Come on, where is it? There we go. So pull it back, and this is what's going to happen. Watch your orbit. Again, the math here is crazy. It's going to pull your orbit around and around and around and around until at one point, doink, you're in orbit. So let's do that. Let's execute that node. Hopefully the ship won't shake itself apart. So what I have to do now, again, I have to get into the position I need to be. Where's the planet here? There's the sun. Can we even see Jupiter? I'm so far away. Its gravity well is so big I can't even see the stupid planet. So yeah, I'm way out here. So almost in my maneuver node. Okay, so I'm at my maneuver node, or I'm at the position I need to be when I get there. Now I'm going to time accelerate into Jupiter. Start now, it'd be nice. Maybe I'll force the issue. There we go. So let's warp it to here. I know there's a planet there somewhere. There it is. Still pretty far away. All right, so. All right. Oh, space is big. So I didn't see Discovery do this in the first movie. It needed to.
Hey, Bob.
Yes.
As a point of trivia about the film 2001,
Yes.
they originally had the idea of chucking atomic bombs out the rear end of the ship to propel it through space. NASA even proposed such an idea, but Kubrick decided that was not viable for his film.
Funny you should mention that. That's called the Orion engine.
Yes.
And there is a mod in
Yes.
the game that you can do that. And you don't want to launch from the surface of the planet with that because it's bad. And it takes your home in orbits and crumples it up and throws it away. So now I'm in an elliptical orbit. So now I'm actually in orbit around Jupiter, and I have decreased my velocity enough that I've pulled my apoapsis down. Now I can change around and go encounter moons and stuff like that. But in order to pull that down, let's see, retrograde, I have still got to accelerate a lot. And the weird thing about it was the closer you get to the body that you're orbiting or maneuvering around, you gotta get the harder you gotta push. And notice this is slowing down. Same with it when you're leaving Earth, when you're pushing, the closer you are to Earth, pushing to go to the moon, you just gotta push harder. The further away that gets, the easier it is. So most of I've heard it saying that what 80% of getting into space is just getting off of Earth. Pretty much true, because look at this. The closer I get to get into a circular orbit, it just takes forever. So again, I never saw that happen in the first movie. So let's do a moon mission. Let's go back to the Space Center, and I'm going to do an entire mission and show you how all this orbital mechanics fits all together. And I'm not going to dock with the space station that's going to blow up, because that's embarrassing. How much time do I have?
You have 9 minutes.
I have 9 minutes. I can land on the moon. Unless if anybody have questions, I can do questions.
I was hoping to ask you the question of which of the major space movies that you've seen lately had, in the past, say, 20 years. We don't have to go back to the 1950s. Worst orbital mechanics made you scream, made you squirm in your seat.
God, all of them. None of them get it right. I'm serious. None of them get it right. There's a lot of them just ignore it and ignore it completely. The one that did it best actually was 2001. There was actually somebody said the docking sequence in 2001, when you're looking at it from the docking port, you're seeing the ship come in and it moves like this and then slows and comes back. That is exactly correct. And again, one person in the audience is going to know that, but that person appreciated that. So a lot of thought went in 2001. Now, the Expanse gets it right, but that's not current technology. Let's kick that up to 100. And I can launch that and let it go. So, let's see. 2010. Again, they sent the probe in, and then they do the aerobraking. The aerobraking was exciting and fairly accurate, but it should have been done first. Interstellar, I'm not even sure what's going on with Interstellar. Gravity, oh heavens, Gravity got it completely wrong. Now remember when I said the International Space Station is 53 degrees. And let's say the shuttle is in an equatorial orbit. If it's not going to the International Space Station, it's not going to be orbiting at 53 degrees. So shuttle gets trashed at an inclination of 0. Oh, look, there's the International Space Station. I can see it right over there. Let's aim right towards it, which you don't do. Thrust right towards it and watch it dip below you, and you're going to miss it completely because it's not what you do. And I've got infinite propellant on, don't I? Yep, sure do. Didn't want that. Oh, let's get rid of these things. Hopefully I won't blow up here now.
Well timed.
Well, I guess I'm not going to show. Well, there's my moon lander. Well, I can show you. Let's see. I'll abort. Let's show you a re-entry, because this is just not going at all like I planned. So you are going to die a horrible fate here. You are in the atmosphere. Remember what I said about aerobraking? So the things to remember about orbital mechanics is nothing works like you think it does. Everything works on the opposite side of the planet of where you are, and TV shows do not get it right. So here we're seeing some atmospheric effects, and I'm not even high enough to burn up. I wonder if I can land this thing in the water.
Save the poor Kerbalites, unless there's none of them on board.
Maybe I won't have a crash here. Do I have enough fuel? Oh my goodness, no.
Feel like it's petering out.
No.
Oh
no! Boosh!
Uh-oh.
Total failure of a mission. So I wanted to show you docking and all this, and that didn't work at all. I wanted to show you landing, but I had infinite fuel on to show you a plane change, so that didn't work. Boy, it was really embarrassing. I actually showed successful docking almost at the Great Lakes Stargaze. I had the wrong size docking port, and it came up and went boink and bounced off in front of a whole bunch of astronomers and my boss. That was really embarrassing. But now I've got everybody here, and I got to watch my entire space station disassemble itself, and I'm not really sure why I did that.
Well, the sad part was the space station disassembled, but we moved on to Jupiter instead of dealing with it.
Yeah, Jupiter is okay. So I did put the Lunar Gateway on here. What I'd like to see is, I don't actually understand. Let's go to the Lunar Gateway right here. Gateway. This is somebody else's model. Hopefully it won't rip itself apart when I go there. Yes, this is called this is actually called the Kraken. There are instances where the physics just goes crazy, and you saw an instance of that. So, but the Lunar Gateway, the plan for this thing is to orbit pretty much like that around the moon, about really close up here, really far down there. And I believe what you do is you rendezvous out here at the AP, which is when you're moving your slowest, and that will this will be a kickoff point to be able to get down to the moon from here or out to Mars from there. So that's pretty much what it's going to look like. It's got docking ports all over the darn thing, because that's what it's going to be. It's going to be a docking hub. So I'm hoping this happens, but we'll see. So I just thought I'd put it in orbit there. So cool. I'm really hoping to see that happen. But I'd like to see a guide for the Lunar Gateway for Kerbal players. You know, this is how it works. Get missions here, dock at the right place, and that kind of stuff. But and there are no official SpaceX parts in Kerbal Space Program, but there are mods that have them, and there are people doing the landing of the boosters and stuff. That I am not doing that, because that's craziness. There's an operating system called the KOS for this, where you can completely automate everything, which is like more than I want to do. But there's a real solar system mod which replaces everything with absolutely authentic parts and more fuels than you knew existed. So this is the first version. This came out in like 2014, 2015. It's been updated fairly frequently, and they're coming out with a second version that's going to have some of the aspects of interstellar travel that you may have seen from science fiction and stuff, nuclear engines, Daedalus, Orions, that kind of stuff, colonizing, that kind of stuff. But they're keeping the physics, and the developer said, I have watched more rocket explosions than I care to think about, because they're going to make the rocket explosions look really cool. So this game has, as I said, it has an educational version called Kerbal EDU that has a whole bunch of physics demos and things in it for your students to do. It's available on Steam. It's available on teachergaming.com. And when I ran my after-school club, the students just love this. I mean, you can build planes, space planes, jets, and I've covered about this much of what this game can do. But you can build rovers, land on other planets, build colonies and bases, and Docking actually works. I have done it.
Bob, I'd like to say that this software is, to me, it exhibits Newton's 3 laws of motion and the universal law of gravity. And when you mentioned about changing inclination of orbit, that makes sense. You've got 6 degrees of freedom. If an object is in motion, it stays in motion. That's one of Newton's laws. It stays in uniform motion. So you have to give it a thrust in a different direction, but it's still going in that motion that it was in primarily before. So this all kind of reinforces Newton's mechanics to me.
Pretty much. No, it implements two body physics, not n body physics. So there's no Lagrange points. They just couldn't do that with the physics engines. But the sphere of influence stuff, it's accurate enough to teach you basic orbital mechanics. And what I wanted to bring up, I wanted to load this back up. It has an in-game Wikipedia, essentially, an in-game wiki that is just fantastic. Where is it? Right there. This thing. They took orbital mechanics and how rocketry is done, and they made it so easy. Where is it? Rocketry, map interface. Here's how to build stuff, space travel. Here's your orbital mechanics. I stole a lot of things from this. They explain. They've taken an incredibly difficult subject and just made it very, very easy. And so there's training missions for the uninitiated, but truthfully, the best way to learn this game is the way I did it with Starbase 1. Have it in a training environment with it running on a whole bunch of students' PC and a teacher showing you what to do. Because if somebody knows what's going on, because we're in sandbox mode here. Look, if I go into the vehicle assembly building and just show you all of the command pods, I mean, I have access to everything in the game in sandbox mode, and it's like, oh my goodness, what do I do with all this stuff? So there's all my command pods, and you've got like those look pretty familiar.
It's 9:32. Do we have
all right
questions for Bob? Looks like Tom in Missouri wants to know if you're flying with a joystick.
No, I'm not, although you can. The joystick, I found the joystick doesn't work as good as I would like it to. It's sensitivity is just ridiculous. You just boink and your ship's going. Woo! So I just don't like the joystick. I use a mouse and a keyboard.
All right. Well, thank you, Bob, for especially coming on at short notice and ruining movies for us. So I already had the same reaction as you did to Gravity in particular.
Oh my goodness. Yeah, it's just let's just point it wherever we need to go and thrust with our little RCS pack and get me 300 meters per second plane change. Nope, not happening.
There's one line in the movie that I used to have the explanation in my head that it's all like an alternate universe that branched off from our reality in 1985. So that's how
where physics doesn't work at all.
Okay. No, more
differently.
All right. So thanks again, and for those of you who are logging off, we will see you at the virtual Cranbrook meeting on April 5th.
I'm going to hang around for a minute and try and get this thing.
I was just going to ask, you mentioned about the not support for 3D, but so it wouldn't, that's like the Halo orbit that the James Webb is going to be using, that wouldn't be supported then.
I'm sorry, I could barely understand you.
The James Webb Space Telescope is going to use that Lagrange. Orbit.
Yeah, the Webb is going to be sitting at the L2 point behind the moon. Yeah, so it just needs to do a little bit of station keeping to maintain that point. That is also where the Chinese have their relay for their Chang'e 4, is it? Or 5?
Yeah.
Their mission on the far side of the moon?
Yeah, they landed that mission on the far side of the moon, and it has a communications relay sitting at the L2 point. doing station keeping out there.
It would make sense.
But like I say, Kerbal Space Program, it does not implement those Lagrangian points. They just couldn't do n body physics. It would bring your PC to its knees.
So it wouldn't, it's kind of surprising that it doesn't support, but I guess it doesn't do 3D then.
So this is gonna work.
I'm going to leave it streaming on YouTube until we get to some resolution on this mission.
Okay, yeah, I'm gonna land. I'm gonna land this. So what you're seeing on the left here is my solid rocket boosters are about half empty. They're gonna kick off. They're starting to see atmospheric drag effects. So those things are gonna kick off.
Bye.
So I've got something called a real plume on. You'll notice the size of the plume behind the rocket gets larger as it gets higher in the atmosphere. This is what actually happens. The plume starts spreading way out. About 30 kilometers, that fairing pops off automatically. So now, my apoapsis is about halfway up to where I want it to be. I'm on a suborbital trajectory. That green line is my communications line back to the radio towers. You can you can turn on individual lines or lines out to all your communications. When you have a lot of communication satellite, it can be kind of crazy looking. So now I'm about to stage here, so that stage is going to break off. In 5, 4, 3, 2, 1. Break off. So that's my second stage. This is a different engine. This has a different ISP. It's meant mainly for working in vacuum. If I used this engine on the surface of the planet, I just wouldn't be getting anywhere at all. So now I need to circularize my orbit. My periapsis here is in the atmosphere. So why is that not have time over? Oh,
what's it going to take to get off of the Martian planet once they get there?
Let's see. Mars's gravity is what, about 1/3? So actually, its gravity well is less. I've seen small rockets used for sample return. The concept was a small rocket. I think what those things do is like what the Chinese done. It'll get you back into orbit, then they do a rendezvous. I can't see a rocket getting from the surface of Mars back all the way back to Earth.
That's what I heard. It gets to an orbit, rendezvous with a vehicle in orbit, and that vehicle will then send it on.
So the concept in the Martian movie was fairly accurate then. At this point in time.
So I'm in a circular orbit here. Now I'm going to do is that home and transfer, and it's going to have it do it automatically. Create and execute. So there's my home orbit. So there's my maneuver node. So I'm going to thrust. My AP is going to push out to this point here, which is where the moon is going to be. So get to that point. So now I am circling around the planet. Oh, okay. Wait for it to go around. Oh, it's a lander. So you're a lander. All right, so it's getting up to this point. 9 minutes, 8, yep. So there's my maneuver node. Now I'm going to look straight down from the North Pole. There's, I'm at my maneuver node. I am facing in the direction I am orbiting, and that's going to push my AP on the other side of the planet, which is just crazy. Notice it's pushing it really, really slow here. And notice once it gets out to about here, it'll start to speed up. Now let's take a look at it from the viewpoint of the moon here. Interesting to watch that whip around like that. All right, so if I do nothing, I will impact the moon here. I don't actually want to do that. So you may have heard of the mid-course correction. Well, that's what I'm going to do. I'm going to set a maneuver node at the mid-course right here. And let's just pull it and watch. I love how you can watch the orbits move around like that. So let's get it to about 20 kilometers above the surface here. 13's a little close. Ah, that's way close. 7, there. Good enough. Execute. So now, back to my probe. Get into the position I need to be at the maneuver node, and then time warp out to the maneuver node. Away from the planet. So I'm at my maneuver node. And now the thrust. This is my thrust down here. It's just gonna do this. This is hardly anything. Yeah, 0.3 seconds burn time. Yeah, so that's really tiny. It's just going right now. All right, so my periapsis is 23 kilometers above the surface, which is good. I won't hit any mountains. So now what I want to do is I want to warp to the sphere of influence right here. So warp to that point, away from the planet, and toward the moon. So when this stops warps, you'll see how far away the sphere of influence is from the moon. About there. So now that I'm in the sphere of influence, the gravitational sphere of influence of the moon. So what I want to do now is go into orbit. So I want to circularize my orbit at, well, actually, I'll just do this manually. Create a maneuver node right here and pull it back. Yoink, until it goes into orbit, then pull it back until it's just about circular. There we go. Execute. So I'm way out here. Got to get in the position I need to go. Now, this is what the Apollo astronauts, Apollo 8 did. They went behind the moon, and that is where they lost contact. And the thrust happens at your periapsis, which happens to be you're not in contact. So planet doesn't see what's going on here. So I'm coming into the moon. I'm just going to let this go. Should see it change your viewpoint for you there. So now, thrust in the direction I'm orbiting, and it pulls me back around. And at one point I go into orbit, so there I go. So now I am in a circular-ish orbit around the moon. So let's land. So let's warp over here. So now I'm going around. The moon's rotating slowly underneath me. Wait for it. All right, so let's create a maneuver node right here. So what I want to do now is, again, I got to slow down to land. I had a maneuver node, and the same thing. What I did to get into the circular orbit, I do again, and I just keep doing it. I decrease my speed till I go suborbital, and that is where. So now I can take this thing and drag it around. I bet the NASA guys would have loved to have had something like this during the Apollo era, huh? So let's drag this. Let's see, I want to move it over there. There we go.
Not what happened to the space station, I'll tell you that.
Oh, yeah. Jeez, oh, Pete.
That would have ruined a lot of people's day.
Yeah, a couple $1 billion down the tube there. So now I am going to pull my orbit down to suborbital here. Changes your perspective for you.
Without question.
Yeah, look at that. And all right, so now I am falling, essentially. Maybe in a few seconds I'll be falling. So I am done thrusting. I don't need this anymore. That is my other stage. And now I am going to turn this off. And I can do this manually, but it will take a long time and I'll likely crash. So I am just going to have it do it for you. So I am falling toward the surface. This is called a suicide bird. What it does is it figures out exactly how far it needs to be up to get down to zero. Now you see that the stage I ejected falling down there. It's going to crash into the surface.
You're gonna do a last-minute burn over the boulders like Neil Armstrong did?
I've done that. Oh god, I'm going right down. So I'm going down the middle of this crater. That's good. It's bad when you land on the side of the crater. I've done that too. And I'm like, no, 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 no.
But if it's a meteor crater, you got a problem because in the middle, there's this little mountain.
Do I see a shadow yet? Where's my shadow? Where's the sun? Directly overhead, so the shadow is going to be there. There's my shadow.
Oh, cool. Well, get those landers out. That is an awfully fine cover. Oh, I see there are rocks there too. I see that.
Oh, yeah.
Yeah, I can see that. Yeah. Those could ruin your day too, but it looks like they're varied enough, right?
Yeah, there's very few of the rocks that are actually
capable of.
Oh my goodness, I'm on a slope here. Yeah.
That's all right. It won't hurt you.
I'm gonna turn my reaction wheel on, so it's
You're gonna be fine.
Ever so slowly.
Yeah, it's all right. You got there. You made it.
And doink, is it gonna fall over? Nope, not gonna fall over.
Nope.
So yeah, so these are your experiments. It's got a bunch of science experiments like temperature and atmosphere, but it's just got tons of different science experiments, and there's mods that have tons more.
Yeah,
and
the Trembley.
So this is like the smallest lander I could make.
The Trembley has, the Trembley has landed. The Trembley.
Is that the WAS has landed?
Yeah.
So that's pretty cool. So there's a bunch of Easter eggs on the moons. There's weird arches. There's a monolith. There's a crashed spaceship somewhere, a UFO. Pretty funny.
Yeah. Did you bring the club flag?
Is the club flag on here? The club flag is on the Orion that I was launching.
Nice.
You better shoot that into the moon then.
Yeah, for sure.
The Orion is what I use. Well, I should have put the flag on it. Sorry.
It's all right. You did fine.
I can't believe that space station disassembled itself. Oh my goodness.
It wasn't
embarrassing.
It's the best.
God.
You know the law of live demos, Bob. If it can go wrong, it will go wrong.
Yep, and I'm glad everybody had
Bob, that was the high
expense.
Bob, that was the high point.
It was made out of Legos.
And I had that rotating torus I put on it and everything because that's what I want them to put on. Actually, there's the book 7 Eve science fiction story. It deals with the International Space Station a couple decades in the future, but they put a rotating torus on it, which just makes a whole bunch of sense.
Sure.
Well, the torus is rotating. It's just that.
It was it's got a counter rotation too, so it's not the torus that tore that apart. I don't know what tore that apart. That was very strange. I put that up there earlier and it worked just fine. Of course, live demo. So this is which would 90.
It's probably a Russian hack.
That was Putin getting revenge, is what it was.
Yeah, right, that was
Nice.
That's cool.
Yeah, so where is it? Open. I had the WASP flag on that. Well, I can put the WASP flag
That was great.
on that.
Bob, that was
So
great.
orbital mechanics is fun, and you can learn a lot from a game. I said I learned everything from a game. Just doesn't sound right. And again, there's also XKCD has another comic that has a guy looking at a plot of some orbital mechanics, and he's saying, "Well, it worked in Kerbal Space Program," and the person behind him was like, "You don't say that at NASA." Again, this ain't real life. There's other things you got to take into account. Again, propellant on here is fuel and oxidizer. And there's mods that have 1,000 different types of fuels and oxidizers. So, but anyway. Does anybody have any questions?
Nice software.
Oh, I love this software.
It was fun.
I've pumped over 4,100 hours and more because I haven't logged a whole bunch of offline time. And designing a rover to work just right, it's got some really cool stuff. You could actually do an entire STEM robotics class with this. Let me go over here. Where's robotics? Robotics. It has all these robotic parts. Pistons, levers, wedges. You can make helicopters and stuff like that. But I've seen people make rovers that unfold from your lander and get plopped down on the ground. So you can do amazing stuff. This has got a complete robotics system that I've barely played with.
It sounds like I'm a retired mechanical engineer, and there's software called multi-body dynamic software out there where you can make mechanisms as opposed to structures, and that's kind of what that looks like. It has joints in it, it has dampers in it, it has springs,
exactly what this
concentrated rigid masses, so you can make various different types of mechanisms, and that's what that kind of looks like.
This yellow thing here is the controller, and you can make something that looks like, if you ever used a video editing package, you can make tracks. You can put things on tracks, and it's really crazy. All the different things you can do with robotics. Like I said, I haven't even touched the robotics stuff. Barely touched the robotic stuff. So anyway, I am going to bail, everyone. Thank you. Thank you for
Thanks.
letting me just from my space station for you.
Thanks. That was good.
Yep. Good.
God.
All righty. Have a good night, everybody.
All right.
Yeah.
Good night, everyone. See you.
Night.
Bye.
Bye, everyone.
Bye.
Bye.
See you, Rayhead.
See you.